Hello friends, welcome back to my channel Chemistry with DB. So in this video I am going to explain the concept of hydrogen bonding. Hydrogen bonding is one of the three intermolecular forces, and the three intermolecular forces that simple molecular structures have are London forces, permanent dipole-dipole, and hydrogen bonding. Out of the three, hydrogen bonding is the strongest intermolecular force. This is present in simple molecular structures which have covalent bonds which are NH, OH or FH. Now this is for the reason that you know that nitrogen, oxygen and fluorine are the three most electronegative atoms which are present amongst all of the elements. So therefore when each of these nitrogen, oxygen or fluorine is bonded covalently to a very small hydrogen atom, then in that case the difference in electronegativity between nitrogen and hydrogen or oxygen and hydrogen, that is quite large, or you can say that the dipoles are very strong. So this is the reason that the intermolecular forces become very high, strong. So now the important physical properties of compounds with hydrogen bonding are different from the others which don't have hydrogen bonding. Now you know that hydrogen bonds are very strong intermolecular force, so therefore molecules are packed more closely together. As a result, if you want to separate the molecules, you would have to provide more energy to overcome these stronger intermolecular forces. So this is the reason that if you have two compounds, one which has hydrogen bonding and the other one which only has London forces or London and dipole-dipole, then in that case the compound with hydrogen bonding is likely to have a relatively higher boiling point. For the same reason, because the molecules are closer together, so therefore you would not find them as gas. In fact, the general state of compounds with hydrogen bonding is generally liquids, and sometimes they can be solids as well. On the other hand, these molecules which have hydrogen bonding, they can form hydrogen bonds with water, ethanol, other polar solvents, so therefore they will freely dissolve in those. However, they will be immiscible in nonpolar solvents. Now, when we have to draw the hydrogen bonds between, let's say for example, two water molecules, then in that case, let's say we have water, we would show it in its original shape, which is a bent shape or V-shaped or non-linear. Now, the first thing we need to remember is that we must show the lone pair on oxygen, and second is that we must show the dipoles. After that, we have to take care that around oxygen it was bent shape because the angle is 104.5. Now we would have another water molecule drawn here with the lone pair dipoles. So we have shown the two water molecules in this manner so that the shape is bent around oxygen, both the oxygens, and it's linear around hydrogen. So after this, what we need to do is label the hydrogen bond, that this is our hydrogen bond. This is very important to show the dotted line as a hydrogen bond. Now let's summarize as to what are the important points you need to take care while drawing the hydrogen bond. First, that you must show the lone pair of electrons, whether it's fluorine, oxygen or nitrogen. Second, you must show the dipoles on fluorine, oxygen, nitrogen and hydrogen as well. Then around oxygen, it should be a bent shape or non-linear, and it should be linear around hydrogen. And last but not the least, label the hydrogen bond. Now let's draw a hydrogen bond between water and ethanol. So let's say we have ethanol O. Again we'll draw bent shape around oxygen. We'll show the lone pair on oxygen, delta negative, delta positive, and then it is for water. So water would be hydrogen, hydrogen. Again lone pair on oxygen, delta negative, delta positive, delta positive, right? So I have met all of the important features for showing the hydrogen bond, and then I would mark or label that this is my hydrogen bond. On the other hand, let's say when we go to drawing hydrogen bond between say water and ammonia, then in that case, then it's a pyramidal shape around nitrogen. Okay, I am showing the lone pair of electron on nitrogen. Dipoles, nitrogen is delta negative, hydrogens are delta positive. And then with water, again I have shown bend shape around oxygen, lone pair, dipoles, and then mark the hydrogen bond. In the same way, if you had to draw it between, for example, two hydrogen fluoride molecules, then it's a linear shape around fluorine as well as hydrogen. So I have just shown the dipoles, lone pair, and then delta positive, delta negative, and then mark the hydrogen bond. I hope you've got a clear idea now how to draw the hydrogen bonds correctly so as to get all of the 2, 3 or 4 marks which are allocated to this question. And if you like this video, then please like, share and subscribe, and I look forward to see you from on my next videos. Bye. Take care.